Welcome back to Ceph Easy. Today, we are going to talk a little bit about how to properly size a Ceph cluster and what we need to discuss. Today with me is my colleague Daniel, that you probably know already from his great break fix session. And if you don't, Daniel has been a Ceph expert for many, many years. He's been in consulting, and now he's joined us in the technical product team. And today he is here to help me answer a couple of common questions about how to properly size a Ceph cluster. And we're trying to keep us short and high level. So this will just be an overview. There probably will be a couple of more sessions where we dive a little bit more into the details, right? So with that, welcome, Daniel. Thanks for being here.
Hi, Chris. Thank you. Thank you for inviting me. Yes, as you said, it's a broad topic, sizing a cluster and things to take into account. So I think that we could start kicking the tires and just going through some of the high-level details.
Right. So for starters, the most common question that I get is people want to build out their Ceph cluster and they don't really know yet whether they are going to use. Ceph provides object, plug, and file. They just don't know. They want to do a POC. What would be a minimal configuration that you would tell people?
Yeah, so for a minimum supported configuration to get started, we will recommend 4 nodes. So having 4 physical bare metal nodes will help. And then really the amount of OSD, so the amount of disks that you're going to have in each of these servers will give you more capacity. So that's also really up to the customer or the person that is going to do the POC, the amount of capacity that they need. But you could perfectly work with 2-3 OSDs per node, and that will give you a starting point for a cluster.
So how many resources are we talking about? CPU, memory, What are we talking there?
Yeah. So just to take into account, and as a disclaimer, let's say, it's true that it could really depend on the use case that you want to cover. If you were more focused on object, if you're more focused on block, it can also cover on the amount of OSDs that you have. But just generally speaking, you would be fine to cover with 32 cores, for example, and 256 gigs, or maybe even 128 gigs would be enough if you have a very low count of OSD. So it really depends, but that would be like a starting point.
Yeah, so 4 nodes, 2 disks each, maybe make them SSDs, and then you're saying 32 cores, between 128 and 256. It depends a little bit on how performant this should run, right?
Yeah, and especially with the amount of OSD. So normally with an OSD that is an NVMe or an SSD, for example, we would recommend 6 cores, between 4 and 8 cores, let's say. You can move around those numbers. So really, if you're only going to have two OSDs in each node, you could really run with even lower than maybe 32 cores, because you're just having 2 drives. 6 and 6 is 12 cores, so really you're reducing the number. So 32 is a good number. If you go lower, maybe you just want to do a POC, you would also be fine. But that's a good starting point for sure. Yeah.
Oh, that's great. Yeah, and then if I ever make up my mind and I say I only need object, for example, or only need block, then we can further constrain the resources, go even lower, right? That's good. So now I started out with my POC, and I like it, and I want to put that into production. What do I need to watch to see if my scale is actually right?
Yeah, that's a good point. And a nice thing, let's say, about Ceph is that you can start small. So you could start with this 4 node kind of configuration, and then you could grow. You could increase the number of nodes. And the really nice thing about Ceph is that when you increase the number of nodes, you increase the number of drives, you're not only adding raw capacity to your cluster, but you're also adding performance. Because how Ceph is architected, it's really a distributed system, so you really increase the performance as you grow. So things to take into account, you could start looking at resource saturation. So if with 4 nodes, you start seeing that your the utilization of your drives is very high, maybe the throughput between the nodes of the network is very high, you can see a bottleneck there. Maybe it's time to start growing and just adding more nodes. No? Adding more nodes is really straightforward in Ceph, as we know from the Ceph Easy series, that you just need to include them in the cluster, and all of the rebalancing of the data is going to happen for us. So it's quite straightforward, increasing the capacity and the performance when you grow horizontally, the number of nodes.
And like we start minimal configuration. Now I've done my POC. What's like the end of scale for Ceph? Like how large can it go?
Yeah, regarding, let's say, limits that we have tested, because this is just limits that we need to test so we can support. You could theoretically go higher than that, but we have, we normally support 2,500 OSDs without a revision, without anyone checking, and then we can go up to 5,000 OSDs if you get IBM to do a review of your architecture, just make sure that everything is good and it makes sense, and then you can go even up to 5,000 OSDs. No, so that's more or less the limit in the ranges that we normally work with.
So 2,500 OSDs times, let's say, 4 terabytes. That's like 10 petabytes of storage, raw storage space that we can provision without even ever talking to IBM and making like a architecture review. Now we can easily double that with just a architecture review, which is probably not a big deal, and that's great.
Yeah, and even take into account, as you said, like 4 terabytes. That's maybe speaking about flash or SSD sizes, but if we're speaking about spinning drives that you can also use with Ceph, you could be easily speaking about 20 terabytes per each OSD, so then you can multiply on the total capacity that you would get with those 2,500 OSD, so it can really grow to huge scale.
Yeah, oh, that's fantastic. Could I even start with small disks and then later on replace them and grow the disk size?
Yeah. So if you make an initial decision to go with a small disk, or even just by evolution, let's say that your Ceph cluster is successful in time, you are going to have to take care of the life cycle of your hardware, of your servers and drives, and maybe those small sizes are not available anymore. So for sure, it's quite straightforward with the use or the help of Ceph ADM to replace drives. So you could have smaller drives and one by one just go replacing them with bigger sizes. Again, Ceph, with the help of Rados, that is the underlying layer that we have, is going to do all of the rebalancing for you of the data. So you can very easily switch drives, go with higher sizes without a lot of pain, no? And without any downtime, that's for sure.
Awesome. Yeah, that definitely sounds good. So are the disks the only thing I need to care about when talking about scaling?
No, and that's a very good point. So we have one side of things that, again, is this, and I would also include like the network throughput. No, so you need to also take into account the NICs that you have, the network throughput, in the sense that if we increase the number of OSDs per node, is more data that we are moving through the network, because we have to remember that Ceph is storage-defined software, so it's going through the network. Now, if we have to give IOPS to the customer, it's going through the network. If we have to do replication, it's going through the network. So we just have to be a little bit careful in the sense of the NICs that we're choosing, that we can move enough traffic from one place to another. That's one thing to take into account. And the other is services. So you could start small with, for example, your MDS service. This is just an example. When we work with CephFS, that is our shared file system, you need a metadata server. That is just a container running on your host. If you start small with, let's say, a small data set, you could just give it a small amount of memory, maybe 6 gigs of RAM, 8 gigs of RAM. But let's say that this is successful, it moves forward, a lot of people start using it, you have a lot more I/O to that file system, then to get better performance, you can just increase that amount of RAM, maybe double it from 8 gigs to 16 gigs, and that's also going to increase the performance because you're really increasing the size of the cache, so you're just getting better performance for your IOPS.
That's a very good point. Yeah, we recently had a customer who tried to put millions of files, so double-digit millions of files into Cephfs, or the shared file system, and they were running with the minimal configuration, minimal amount of resources, and they were surprised that that the performance wasn't good enough. It still worked, but yes, it's a very good point.
Yeah, that's why I wanted to bring up this topic in the sense that you can see recommendations, maybe use these CPUs, use this memory, but it's always going to work with less because it just works, no? But if you want to get an acceptable performance, you need to grow your resources accordingly to the load that you have, no?
So are there any resources, documentation people could read up on, a couple of more details maybe?
Yes, I think that we can leave some links in the description if you like, and we have the documentation, the hardware guides that gives you example depending on the use case that you're thinking on using. As we said, maybe you want to go like IOPS low latency workload, or maybe you just want to go like to an archive thing where you're not really worried about the performance, you're just worried about reducing the costs of the solution. So we have those examples in the hardware guide, and we can leave that in the link, with a link in the description.
Okay, I think that's great for a quick overview. I'm fairly sure we will be back with more details on Ceph sizing. Leave us a couple of comments down below the video, and we'll try to weave them into the next videos. And just like and subscribe the video. See you around. Bye-bye.
Thank you. Bye.